Hello, Namaskar, Vanakkam. My name is Sudhir Sahasranaman and you're watching CBSE with Sudhir. Let's come to the last chapter of your Science Class 7 Curiosity textbook, that is Earth, Moon and the Sun. Just like it was in Class 6, this is the last chapter of Class 7 relating to the outer space. And we are going to talk about our dear Mother Earth. We are going to talk about a satellite, our natural satellite, the Moon, and we are going to talk about the Sun, around who the earth revolves and revolves. Okay, rotates so apne aap hoga. Okay, so CBSE with Sudhir, Science with Sudhir sir is your hashtag. Okay, so let's get started. I've also put the PDF of the chapter as per your NCERT textbook. So we are essentially talking about, let's look at what exactly this chapter is all about. We are going to talk about the day and night cycle, but before we do that, let's look at a particular story. So you have Kanyakumari, which is in Tamil Nadu, the southernmost tip of India. There, 12-year-old Rashmika was cycling to school. Now, what did she observe? And she obviously is a student who observes, which is so important when it comes to matters of science. She was excited that day because her science teacher had dedicated a class for students to share and try to explain interesting observations. Now, what were the observations that we were speaking about? That the coconut tree shadows were long in the morning, right? And we have studied this in the light chapter. Please go and take a look at that video, which I'm very happy about. So please go and have a look at it, done both in English and Hindi separately. Okay, but long in the morning, but shorter in the afternoon on her way back. So when in the afternoon, and I'm sure you can say this because we have studied about shadows. Because in the morning, the sun is rising from here. So if the coconut tree is here, its shadow will be long and falling on the ground in a long manner. But when the sun is up in the afternoon, by which time Rashmika comes back from school, it is right on top. So the shadow will be short and it will be very close to the actual tree. So that is what she observes. If she had seen our video, she wouldn't be wondering why it is so. So the size of the shadows here, because the sun moved across the sky during the day, but she also remembered learning that the earth moved around the sun. So she's wondering that, well, yes, earth moves around the sun, right? The sun doesn't move, though we get the feeling that the sun is moving from east to west through the 12-hour journey, right? In the morning and in the evening it sets in the west. But no, the sun is not moving. We are moving around the sun, because of which, and we are also rotating on our axis, because of which day and night takes place. So there are two movements taking place about which we will study in this chapter: rotating on its axis and revolving around the sun. Please understand the difference. These two are different concepts. Okay, so that's what she wonders about, why this is happening. So you see, these are the shadows, you know, the cycle shadows, because the sun will be somewhere this side. That's why the shadows are this side. If the sun was this side, the shadows will be not this side, but that side of the cycle, right? I hope you know that, because these are the kind of questions that will be asked. Now let's look at this. Okay. Okay, before we get into this, I will go with my notes, because I've made specific notes, so it will be easier for you to understand in a concise manner. So what are we essentially talking about here? A globe represents the earth. I don't know if you have a globe at home. I used to have it when I was a child. We used to have a globe, and I used to keep looking at different countries around the world and know their names and capitals. It makes so much of a difference to your understanding of geography, right? So a globe represents the earth. Rotation, please understand this definition. Rotation is defined as the motion of an object in which all its parts move in circles around an imaginary line that passes through it. This is the technical definition. I will make you understand this. This imaginary line is known as the axis of rotation. That is, if you have a ball, my ball was taken by somebody, so I don't have it with me right now, and I don't have any other round object. Okay. This is not exactly round, but let's make do with it. So if this is a round, so it kind of keeps rotating like this. Okay, it keeps rotating like this around. So this, through this and this, will be the axis of rotation, right? So rotation is defined as the motion of an object in which all its parts move in circles around an imaginary line, which is known as the axis of rotation. Using a torch to represent the sun. Now let's look at this book, which will make it more clear. So what you do, if you see this kind of a merry-go-round, and I'm sure you would have played on this in your neighborhood park. So if you sit on this and you keep moving it in an anti-clockwise direction, what is an anti-clockwise direction? Clockwise is when it moves in the same direction as in the clock. So if this is the clock, if you move like this is clockwise. But if you move like this in this direction, as this merry-go-round is doing, because it's moving like this, so that means it is moving ulta, not in the clockwise but in the anti-clockwise direction. So while you turn in the anti-clockwise direction, the objects appear to turn around you in the opposite direction. है ना? If you move like this, you will feel like, as though the other objects are going in the opposite direction, that in the clockwise direction. So when you move anti-clockwise, the objects will seem to be moving in this direction. Seem to be moving. They are not moving, but they will appear to be moving, right? Now fix your gaze at a particular tree. So what you are saying is that when you sit on a merry-go-round and you see a particular tree, how it moves, right? So you will feel as if that is moving in the clockwise direction while you are moving in the anti-clockwise direction. Okay, so in which direction? The tree appears to move around in the opposite direction, that is the clockwise direction. The tree appears in your view from your left hand side and then moves out of your view and then comes in the right hand side view. Okay, so that is how it is. The same concept is about the earth moving on its axis, as in rotating. Revolving we will come to after a little while. The fact is that the sun appears to be moving because we view it from the earth, which is turning around itself. So because we are turning, we feel the sun is moving. No, it is it's like in human beings, we think that person is doing something against me. No, it is because of the way you think that that person may not even be thinking about you. The sun is not thinking about the earth, but because the earth is moving in a certain direction, the earth feels, oh, the sun is moving. The sun is not moving my sun, it is the earth which is moving. You understand this? Okay, now let's go forward. So similarly, you see, I don't know if you have ever played with this thing, spinning top, as a child, a spinning top, or you look at the ceiling fan. In what direction does it move? It moves in an anti-clockwise direction. The moment you switch on the fan moves in an anti-clockwise direction. A spinning ball, you keep a ball like a basketball, you keep it, I don't know how good at you are, you this thing it and you move it like this, it will move again in an anti-clockwise direction. In a similar manner, the earth also spins or rotates on its own axis in space, as shown in figure 12.3. Like this is the figure I will explain to you. The earth's axis of rotation passes through the geographical North Pole. Now we have studied this in geography. Let me explain this to you. Now this is the North Pole. This is the South Pole, right? Now the earth is moving like this from west to, so when you see it from the top, just imagine that your eyes are right here on top. So when you see from the top, let me just imagine that I am standing at the North Pole. Just imagine that I am standing on the North Pole. When I am standing here and the earth is there, the earth will move like this in this direction, which is the anti-clockwise direction. It is moving from here like this. Sorry, like this. It is moving in this kind of a direction, right? So when viewed from the top of the North Pole, the earth is rotating in the anti-clockwise direction, that is from west to east, which is why you feel that the sun is moving from east to west. The same concept as when you are seeing the tree or a building from the merry-go-round, which is moving in the anti-clockwise direction. I hope you are understanding this. The sun is not moving, the earth is rotating, and therefore you feel that the sun is moving from east to west. You understand this? Now, let us try to understand this with the help of a globe. So, we have used this globe. So, this is how you understand this. Imagine yourself standing on the North Pole. From the South Pole, obviously, it will be different because now you will be looking at it like this and you will think that it is moving like this. Okay, it is moving in this direction. Now, so if you put a particular sticker on any country, let's say you put it on India, and then you see how India is moving, right? And then if you put an imaginary sun outside, and then you see from the perspective of India, how you would feel the movement of the sun. These are all activities that you can do because that will make you understand this whole concept much better, right? Should not be any confusion at all. Okay, right? Now let's move forward. All this is done. So rotation is the motion of an object in which all its parts move in circles around an imaginary line that passes through it. This line is called the axis of rotation. This is the definition of rotation that you should remember. Please do that. Okay. Now let's move forward. Now this is an interesting activity. Maza aayega. So what you do is to keep a completely darkened room. Okay. In a darkened room, put that globe in front of you. Okay. And then you also get hold of a torch. Now with the help of a torch, you put the thing. Now this torch is what? This torch is not a torch. This torch is acting like the sun for us, right? So when the sun is here, you see this half of the earth is completely illuminated. That means it is daytime in this part of the globe. This part of the globe, the other side, which is not receiving the sun rays, or in this case, the light of the torch, that will be night time. That's how day and night takes place. So when it is day in India, it will be night in the other side of the globe, that is countries like the USA and Canada. When the light is falling on USA and Canada, it will be night time in India and other countries in Asia. That's how it operates, because we are almost, not completely, almost 180 degrees from each other. If India is here, America is here. Like you see, Australia is here, right? Australia is here. India will be somewhere here. So India will be almost at the edge. You know, it is like, you know, it's evening time at that time, or morning time. You can think of it depending on how the movement is happening. So it is day in that half of the globe which receives light, and night time in the other half. Clear? Now in India, sunrise first occurs in the eastern part, which is why you will see, if you are in a state like, let's say, Assam or Meghalaya, in the northeastern part of India, you will find that the daylight comes earlier for you as compared to, let's say, a Rajkot or a Gandhinagar or an Ahmedabad in Gujarat, right? Which is in the western part of India. It will be 1 hour, half an hour. The daylight will strike earlier in Assam as compared to Gujarat and Rajasthan. Again, the concept, and you will get these kind of questions. I will make test paper for you, and you will find it very interesting. You will get these kind of questions which will give you practical examples, that why does the sun rise earlier in Guwahati as compared to Surat in Gujarat, right? So what is the difference? So the light falls on the eastern part of India first when the globe rotates from west to east with respect to the north-south axis. Now, while rotating the globe from west to east, observe your location on the earth. Let's say you are on India, right? Does it go through a cycle of day and night? You know, how does the whole thing manifest itself? You know, how does it move when the torch is there? Please do this activity. It will really help you understand the rotation concept that much better. When you do it yourself, it will really help. So it is like this, you know, the sun's rays are like this. This part, like you see, India is here. So this part is where the day is coming. This part is entirely night time, and it will be moving like this. You know, it will be moving. Now it is evening time. It is now going to become night time here, because it is going to move like this. Okay. Now imagine that you are standing on the equator of the earth and watching the sky during one rotation of the earth. Now let's imagine that you are right at the center. That is the central point, which is the imaginary line, which is called the equator, the hottest places, right? From west to east. What will you observe? So what will happen is that if you are here at the equator, right? Let's start from here. I am facing north and my back is to the south, right? If you are here, right? I am facing the northern direction. I'm facing the northern direction, and the morning sun appears in my view to my right on the east, because this is the eastern direction and I'm standing here, right? So east, west, and I'm facing the north, right? So, and then the earth moves here, right? And by noon, I have rotated to a new position. From here, she's now here, right? She's not here. She's at the same place, but the earth has rotated. Around noon, I have rotated to a new position where the sun is now over my head, right? And by evening, you find that this rotated further and the sun has started to disappear from my view to the left. From the west, the stars are now visible in the night sky. So while this girl is at the same position, because of the rotation of the earth, it looks as though the sun has moved. The sun doesn't move, it is the earth which has rotated. So due to the rotation of the earth, the sun appears to rise in the eastward direction, move across the sky from the east to the west, and then the night becomes and the stars become visible in the sky. Okay, let me look at my notes and just see if there is something more. So using a torch, so when the light is shined, let me just do a quick recap. When the light is shined on the globe, half of the globe receives light daytime and the other half remains dark nighttime. Clear? When the globe rotates from the west to the east with respect to the north-south axis, the light falls on the eastern part of India first. This is a definite question from this chapter. As a location on earth moves into light, sunrise occurs. As it moves into darkness, sunset occurs. The earth's rotation from west to east, from the western to the eastern direction, causes the day and night cycle. The side facing the sun has daytime, the other side has night. So this is what now we come back to Rashmika and Kanyakumari. This is the famous Swami Vivekananda statue. This is the Tiruvallur statue, and these are the coconut trees. So Rashmika, she thought that the sun moved across the sky, but she also recalled learning that the earth moves around the sun. This made her puzzled about whether the sun moves or the earth moves. But now all of you know why this happens. Clear? Now, again, we come to the recap. You might have noticed sunrise in the east, activity, this thing. So if you sit on a merry-go-round, this is what happens. If you focus on a tree while the merry-go-round turns anti-clockwise, the tree will appear to be moving around you in a clockwise direction, coming into view from your left and moving out of your view on the right. Do these two experiments, the torch experiment and the merry-go-round experiment, as you are seeing here, right? I'm sure all of you have taken a ride on these merry-go-rounds, but now you can understand it from the point of view of science and understand your chapter number 12. So now let's look at the Earth's rotation explained. So when we observe from Earth, when we are looking upwards from Earth, the sun appears to move from east to west across the sky. This is because the Earth itself is turning around its own axis. The Earth is moving around on its own axis and the sun only appears to move, right? That's why I put it in italics. This Earth spins or rotates. Spinning or rotating means the same thing on its own axis in space, similar to a spinning top, a spinning fan, or a spinning ball, right? The Earth's axis of rotation is an imaginary line. There is no line which is there. That is, scientists have done this so that it's easier to understand and explain. That passes through its geographical north pole to south pole, the ball, and the north pole to south pole. The Earth completes one rotation in approximately 24 hours is when one entire rotation is completed. That's how day and night happen. When viewed from above the North Pole, the Earth rotates in an anti-clockwise direction, specifically from west to east. I've done this now twice. I hope it is absolutely clear. I've taught it and also revised it. Now, let's move forward to the next part of the chapter. Now, this is something very interesting that we had studied about Galileo and the church, the pendulum, remember, in the earlier chapter. Now, what happened was that he discovered the property of the pendulum, and in 17th century, another scientist called Huygens used that property to make pendulum clocks that measured time. In the middle of the 19th century, that is somewhere around 1850, right? Another scientist called Foucault used a long pendulum to give the first simple demonstration of the Earth's rotation. The pendulum, known as Foucault pendulum, in his honor, consists of a long string with a heavy bob, that is a long thing like this, and then there is a bob at the thing, the way the pendulum of a clock looks like this and like this. This is called the bob. Okay, this is called the bob, and this is the long string suspended from a ceiling. You know, he has suspended it from a ceiling. A Foucault pendulum with a length of 22 meters has been hung from a skylight in the Constitution Hall of the new Parliament building in Delhi. It symbolizes the integration of the idea of India with the vastness of the cosmos. That is, India is connected to the entire outer space, the solar system. So we are just trying to convey that by using this kind of a Foucault pendulum, right? So I'll just show it to you. So due to the sun rises, this is something we have studied. So in the middle, Foucault used a long pendulum and this is what is there in our new parliament building, which has been constructed in Delhi. Okay, now let's move to stars. Okay, we have completed about Earth, and now we will go to stars. Okay, now this is slightly more complicated. Now, since the Earth is rotating, the question arises, since the Earth is rotating, shouldn't the stars also appear to be rotating? Now, that's an interesting kind of a question. It should seem to be moving. If you look at the stars, they will also have some kind of effect. What kind of effect is there? Let's understand that. So this is activity 12.3. In fact, as I have told you before also in earlier videos also, my class 12 project was on astronomy, right? So I used to go 15 days I did the project. So 15 days I used to go to the terrace of my building. When I was growing up, I was in Delhi, and I used to keep looking up and one had to make the exact position of the stars. Okay, we had to make the exact position of the stars, and that was the project for 15 days. 3 of us were doing it independently. So, and I still remember, one of them is now a lawyer, a big top shot lawyer in Delhi. Another one is in the USA. So, Binasha and Suman. 3 of us were doing this. So, and then the next day, what used to happen in those days in Times of India, the chart used to come. So then what you have drawn, you would also get to compare it with the actual chart which would be put out by an organization. So let's understand this. So on an early evening between March and May, identify the Big Dipper, which is the Saptarishi, and the pole star, Dhruv Tara, if they are visible. This we have already studied in class 6. Now you note down your observations, whatever you see from the night sky, especially if it is a clear night sky, not a cloudy thing. So let's understand. You do this activity. The finding is that the Earth's axis of rotation points very close to the pole star in the north hemisphere. You know, the axis of rotation is very close to the pole star. Therefore, the pole star appears stationary. The reason the pole star looks like it is stationary, ye hilta nahi hai, it does not move from its position at all, is because it is very close to the axis of rotation. So this is also an illusion of time. Therefore, the pole star appears nearly stationary in the sky. This can be asked as a reasoning question. Why does the pole star appear stationary? It appears stationary because the Earth's axis of rotation points very close to the pole star in the northern hemisphere. All the stars appear to move around the Dhruv Tara. Just like the sun, the moon too also appears to rise in the eastward direction and set in the westward direction because the Earth rotates from west to east, right? Now, the interesting thing about the Earth and the moon is that just like the Earth is rotating and revolving around the sun, the moon is revolving around the Earth, right? And that is what leads to eclipses, because sometimes the 3 of them come in the same line. And that's what leads to lunar and solar eclipses. We will study about that a little while. Just a few days back, we had a lunar eclipse visible in India. I remember going to the terrace late in the night to see the blood red moon, and the solar eclipse, which of course was not visible in India around September 21. Right? So these are some of the photographs. Astrophotographers take long exposure photographs, keeping the camera shutter open for a long time. In such a photograph, the apparent motion of these stars is recorded as arcs of a circle known as star trails. So it looks like this. These are very high resolution cameras, not the kind of cameras that we have on our mobile phones. Okay. Now, this is about Aryabhata. Okay. This is again in this thing. So what I've done in the notes is to almost help you with the revision part. So if you look at this, these are concise, crisp, pointed notes. When observing the Big Dipper Saptarishi over several hours, it appears to move around it. I've already explained that. The pole star appears stationary because the Earth's axis of rotation points very close to it in the northern hemisphere. I've written it like an answer, and that's what you need to do. Please take a screenshot so that you can make a note of it in your notebook, right? All the other stars, similar to the moon also appears to move. So now let's understand about Aryabhata. Now, who was Aryabhata? He was in the 5th century Common Era. Observed the daily apparent motion of celestial objects like the sun, moon, planets, and the stars. So he was observing how the moon moved, how the earth moved, the stars, etc. Right? Now, Aryabhata wrote this book called Aryabhatiya. Explained the motion of stars due to the Earth's rotation. Okay, he compared it. Likened means he compared it to a person in a moving boat. If your boat is moving, seeing stationary object appear to move backward. So when you are going in a boat, whatever building or trees that you see on both sides of the river bank, they will appear to be moving, like when you go in a train, for example, or in a bus, right? When you're moving like this, and especially in a train, you will feel like the other things are moving backward very, very fast, because you are going in a very fast, with a very high speed in a particular direction. Similarly, stationary stars are seen by people on Earth as moving towards the west. Aryabhata calculated for Earth's rotation, and he said that this would be approximately 23 hours 56 minutes 4.1 seconds. So he's so close, just short by about 3 odd minutes, right? Is impressively close to the modern accepted value. So he said that the Earth takes, Aryabhata calculated, imagine in the 5th century Common Era, he calculated and he said that the Earth takes 23 hours 56 minutes 4.1 seconds, that precise, in order to rotate. So he's so close, just short by about 3.5 odd minutes. Now, let's now move to the revolution of the Earth and the seasons. I hope everything is clear till here. Okay, so this is all about Aryabhata. Okay, now let's understand about the revolution of the Earth. Now, what is the definition of revolution? Rotation, I have told you. Revolution is the motion of an object around another object. That is, you have, if this is the sun and this is the Earth, right? So the Earth is moving like this around the sun, right? And that is what leads to seasons. Of course, this Earth is also moving like this at the same time. It is moving like this, and that is causing day and night. And when it moves at the same time, it also moves around the sun. This movement takes 24 hours. This movement around the sun takes approximately 365 days. That is why we have 365 days in a year and 24 hours in a day. Is this clear? Now, so revolution is the motion of an object around another object. Okay. So the path of an object takes while revolving around another object is called its orbit. So there are, around the sun, there are many planets. You have Mercury, Mars, Neptune, Uranus, etc., right? Jupiter, Earth. So you move like this. Okay, you're moving like this. Everything has an orbit. It's not like, Earth will go and clash with Venus or with another planet. No. Everybody has been given their own road to move on. Okay, so they move in this circular kind of a manner around the sun, and that is what is called the orbit. If viewed from the top, the orbit of the Earth around the sun is nearly circular, not exactly circular, slightly wider than circular. The orbit appears elongated because it was a side view of the orbit. The Earth completes one revolution around the sun in about 365 days and 6 hours. Okay. So this is what happens. So when viewed from the top, it appears elongated. It completes 365 days and 6 hours. The Earth's axis of rotation is not upright with respect to the orbit. It's tilted because the Earth is like this. When it is rotating, it is not like this. It is the Earth's axis of rotation is a bit tilted. The Earth maintains this tilt as it orbits around the sun. The tilt of the Earth's axis and the spherical shape of the Earth gives rise to season, right? The tilt of the Earth and the spherical shape of the Earth. Before we come to the solar eclipse, so so the changing view. So here you see, if you see this particular illustration, you will know what I'm talking about. Every evening the sun sets the west and the night sky becomes visible. We know that this occurs due to the Earth's rotation. As the Earth also revolves around the sun continuously, the stars seen in the night sky after sunset gradually change over a year as we look in different directions as shown. So what happens is that the stars that you see, let's say in the month of April, will be in a different direction when you see them in November, right? Because it will be different because the Earth is also revolving around the sun at the same time. So they will not be seen in the same position in the sky as it is in the month of March. So there will be some shift also, right? So in the month of March, right, the sun is like this, and it is in September, it is like this. So you will see different kinds of stars at different points in time. So here you will see this side, you will see this side out here. So different stars rise at sunset in different months, right? So stars that set as sunrise, you see this side here, because the Earth is continuously rotating and revolving around the sun. So when in the month of March, you are seeing that the sun, if the earth is like this, at this position around the, with respect to the sun, we are at this position. It's like this. For example, let me take an example. If your school is somewhere here, right, and you are revolving around the school, right? So from here, you may see the front gate of your school, right, from this side. But when you go this side and complete 180 degrees, you will see the back gate of the school. When you are at this side, you will see the side gate. From this side, you will see the other side gate. So your view of the same school building changes according to which position you are. The same way, from when you are here, the night sky appears differently from how it will be when you are at this space, right? Because now you are seeing it from this angle. So the angle, dekhne ka nazariya, the angle of seeing becomes a little different. You understood this? The Bhil and Pawara are indigenous communities from the Tapi Valley in western India who use the appearance of certain patterns of stars in the sky as markers for the arrival of the monsoon rain. Because you see a certain stars and you get an idea that, okay, this means that this is the time when the monsoon will arrive in India. So these are all in ancient times when sophisticated machines were not there, gadgets were not there, tools were not there. People would predict the different weather patterns. So let's now come to the seasons on the earth. So the earth's axis of rotation. So these are some of the observations the boy and the girl are making, that we go through a cycle of seasons, etc. We have already spoken about that even in geography. The earth's axis of rotation, please go and see the 3 very detailed videos that I have done on understanding of the weather, the climates, and the first chapter on the geographical diversity. Our social science playlist is absolutely top notch, done both in English and Hindi. The Earth's axis of rotation is not upright with respect to the orbit, but it is tilted. As I said, it's a little teda, right? Hum sab tede hain. Okay, the Earth maintains this tilt as it orbits around the sun. The tilt of the Earth's axis and the sphere, but it doesn't mean that when you are standing in buildings, you will also be teda. No, with respect to the entire Earth, we may be teda, but on the Earth, we are all standing there. Because these kind of questions you should get in your mind, right? The tilt of the Earth's axis and the spherical shape of the Earth gives rise to seasons. Let us find out how. Now, this is again the same thing, right? You have the sun in the middle. This is the month of March, right? This is the axis of rotation, a little tilted, right? So when it moves like this, right? When it moves like this part is getting the sun, the summer in the northern hemisphere in the month of June. Then it comes here. So when you're seeing it from there, you are saying that that part is getting the sun, this part is entirely night. And so you see different parts are getting the sun, the longer time, the summer, the winter, etc. will be there. So different positions of the earth while revolving around the sun. The earth's orbit appears elongated because this is a side view and not the top view. The sizes and distances are obviously not to scale. But what I'm trying to say is that this is how the seasons change. It depends on which side is facing the sun for a longer period of time and depending on its movement around the sun. So in June, the northern hemisphere is tilted towards the sun. In the month of June, the northern hemisphere is tilted like this side, the northern side, the southern side is moving the other side, right? While the southern hemisphere is tilted away from the sun. A given amount of sun rays are spread in a smaller area in the northern hemisphere as compared to the southern hemisphere due to the spherical shape. So that area is heated more. So you see out here, this side will get more sun. So this side is getting more heated, right? This side is not getting heated because it is away from the sun. It is moving away from the sun. So it will be comparatively less warm, less hot, and more cold because it is not getting the rays of the sun. Further, the northern hemisphere receives sunlight for more than 12 hours in June. So the northern hemisphere receives more intense sunlight. That's why the summers will be a little more harsh in the northern hemisphere in the month of June. In December, the situation is opposite in the northern hemisphere and it experiences winter season where sunlight is for shorter time. So depending on the movement around the sun, which side is getting exposed, the northern hemisphere or the southern hemisphere, your summers and winters become more intense accordingly, right? Now, this makes it very clear. So you see out here, the same amount of sun rays are spread in a smaller area in this hemisphere, hence they are more intense. So in the center of the thing, so where the sun is there, when it is hitting directly, this yellow patch that you see, that's where it will be intense, and that part, the equator part, will be the hottest part, right? But equator or the area away from the equator, depending on the angle at which the sun rays are hitting. But the sun rays which will hit here will be less intense because it will have to go like this. Similarly, here also the same amount of sun rays are spread over a larger area. So the heat that will be in this part will be less intense compared to this part. You're getting this point? It will be less intense in this part and this part compared to this part, right? So where it's like, you put a torch, you put it at one particular place, there will be intensity. But the area above and below, it will be slightly less intense. It's the same concept of the sun with relation to the earth. And the opposite will happen in the months of December, when you see in December out there. So the North Pole receives sunlight for all 24 hours in the month of June. In the month of June, places in this hemisphere receive sunlight for more than 12 hours during. In fact, when I first went to UK in 2001, I remember, what time the sun would set? 10 p.m. till 10 o'clock. 10 o'clock would seem like 5 o'clock in the evening, right? So 10 o'clock is when the night would come. So it would be very, very strange kind of an atmosphere. Your body clock goes for a toss. You wonder, why 10 o'clock seems like 5:30 in the evening, right? So that would be the difference. So places, because that is in the northern hemisphere. So places in this hemisphere receive sunlight for more than 12 hours during the 24-hour rotation of the earth. I just gave you the example of, I was in a place called Cardiff, which is about 5 hours from London, right? So you get sunlight for more time. Places in this hemisphere are in darkness for more than 12 hours during the thing. Whereas the bottom part, you will find more. If you are in southern hemisphere, you will find it in Antarctica, etc. You will be in darkness for more amount of time. Whereas in the month of December, if you go to the northern hemisphere countries, northern Europe, in the months of December, you will find that the North Pole is in darkness for almost all 24 hours. Okay. Whereas the southern pole will not be the same. It will be having more of light in the months of December. It will have longer days. So that's how it happens. The seasons and the length of daytime are reversed in the southern hemisphere as compared to the northern hemisphere. Hence there it is winter in June and summer in December. So in the southern hemisphere, you will find that if you go in the month of December, it will be actually warm, whereas it will be winter and very cold in the month of June. That is the interesting thing. So when you go to celebrate Christmas in the southern hemisphere in December, you will find that it is actually very warm. But Christmas in the northern hemisphere will be extremely cold. Please remember this. If I were setting your paper, I would ask you questions like this, that why does it happen like that, so that you're able to use practical examples. That's how you need to prepare for competency focused questions. So two incorrect reasons often given to explain why seasons occur on the earth are: when the northern hemisphere tilts towards the sun, it is closer to the sun. The orbit of these are the incorrect reasons. The orbit of the earth is an oval while the sun is slightly displaced. No, the actual reason is the difference in distance in either of these cases is very small, and these are not the reasons why seasons occurs. In fact, the earth is closest to the sun in January. So the seasons why they occur, I've explained that in the geography lessons in social science. Please see those videos. Now, in the northern hemisphere, the longest day occurs around 21st of June. This is known as the summer solstice. Okay, 21st June is after the summer solstice, the duration of a day becomes shorter. So 21st of June will be the longest day. 22nd of December is the shortest day and the longest night in the hemisphere. So that is the ulta. 22nd December and 21st of June, you need to remember. Around 21st of March and 23rd of September, daytime exists for 12 hours. In the northern hemisphere, these days are called the spring and the autumn equinox respectively. This can come as MCQ or fill in the blanks or true or false questions. So please, you need to know these facts. At the North Pole, the sun rises in the east direction or the equinox, that is 21st March, and remains continuous to the sky for 6 months. The sun sets on 22nd December. So but I said no, that the daylight is almost continuous. That is, it rises on 21st of March and remains continuous high and sets only on 22nd September. So this exists for almost period of 6 months. The South Pole experiences the opposite, right? That time, between this time, it will be darkness, and the other time is when it will be completely daytime. Okay. Now, what happens on the equator? Now, you would think that, okay, North Pole understood, South Pole understood. What happens around the imaginary line called the equator, which is the center of the earth? There is always 12 hours of sunlight and harsh, strong sunlight, right? And 12 hours of darkness. There is little difference in the intensity of the sunrays falling on the equator in different months. Thus, for southern states of India, that's why you will find that the southern states, which are closer to the equator as compared to the states in the northern part of India, they are more cold, of course, also because of the Himalayan region, but they are more cold also because they are away from the equator as compared to states in the southern part. Southern part are closer to the equator. So that is another reason why you have more strong summers in the southern part. Now let's come to the eclipses. What exactly happens during an eclipse? Now, the first thing you need to understand is the solar eclipse. Before that, basic concept of eclipse we understand that you have planets like Mercury and Venus, which are closer to the earth. They appear very small compared to the sun and never block the entire light from the sun. Okay. However, you will be surprised that the moon can do that. Okay, so that's how the solar and the lunar eclipse happened, when the sun, earth and the moon appear in one line, of course, depending on which is blocking whose rays. Very interesting, the entire concept is. So solar eclipse, what exactly happens? Let me show you from here. A solar eclipse occurs when the moon comes in between the sun and the earth. Okay, so the moon is in the center. So it is SME. Okay, that's how you need to remember. SME is when the solar eclipse happens. Solar eclipse happens SME. Okay. Moon comes between the sun and the earth, obstructing the light of the sun from reaching the earth, right? The moon, therefore, it appears to be dark. When the full solar eclipse happens, the earth appears dark because the moon is coming in between and blocking the light of the sun, preventing it from hitting the earth. The moon, though much smaller than the earth, sun in physical size, can appear to cover the entire sun because the moon is much closer to the earth. We studied that in the light chapter. When it is closer to the earth, it can seem like it's covering the entire earth. You would now ask, why is the solar eclipse? Why was a solar eclipse on 21st of September not visible from India? Because at that time we were on the other side because of the earth's rotation. We were in the night time, so we did not see the solar eclipse. You understand that? So the apparent size of an object, how big it looks, depends on both its actual physical size and its distance from the observer. So the moon is closer to the earth, not to the sun. So therefore, it can even cover the most portion of the earth. So total solar eclipse occurs in areas of total darkness where no part of the sun can be seen. During a total solar eclipse, it turns dark during the day for a few minutes. Partial solar eclipses, when not the entire portion is covered, occurs in areas where the moon only partially blocks some regions of the sun. So some regions of the sun, if they are blocked by the sun, by the moon, then it is a partial solar eclipse. A total solar eclipse is when the moon completely covers the sun. So this is how okay, so this is an activity which you are doing with the thumb. You see something like I'm seeing a photograph out here. With a thumb, it looks as though I have covered the entire photograph. It's like that, right? Depends on the distance and depends on in which direction you are putting something. So that is an activity that you can use in order to understand how does it work. All this I have already told you. Total solar. Okay, this is how it is. Okay, this is how this whole thing happens. So this is the earth. This is the moon, which is much smaller. And this is the sun. So when the sun is coming, the moon is kind of blocking. So at this side, this portion, this shadow that you are seeing, this entire portion that you are seeing will be total solar eclipse, because here it is looking like it is completely blocking the entire space. So when I am seeing my thumb is small. The photograph that I have out there is very big. But because of the way I'm putting it, it looks as if I have completely covered the entire photograph. Even though the photograph, which is the sun, is much bigger than the thumb, which is the moon, right? So here I am the earth. I am not able to see the photograph at all. So this comes and completely covers, this is the total solar eclipse. The remaining areas will be partial solar eclipse because some part is getting covered. This is the other side where it is night, so you are not getting to see the solar eclipse at all. So this is the partial solar eclipse, and this is how the solar eclipse essentially looks like, where it is gets covered. It becomes dark even at noon or 3 o'clock. It becomes dark because the sun is getting covered by the moon. So for the safe viewing, etc., you need to, because seeing the sun during a solar eclipse is considered dangerous. You can lose sight. You have to be very careful about it. So directly viewing a solar eclipse is extremely dangerous and cause eye damage and blindness. Do not view it through sunglasses. You need special telescopes to watch it. High powered, normal telescopes, etc., can damage your eyes. You have to be very, very careful. So only in an astronomy club or in a planetarium where they have really safe telescopes, you can watch something like this. Okay. Now, what happens in the case of a lunar eclipse? In a lunar eclipse, the earth comes in between the sun and the moon. So the sun's rays, because the moon doesn't have any lights of its own, we studied that in the light chapter. So you are preventing the light from falling on the moon, the sun's light falling on the moon. So the earth comes in between. So here you need to remember it as SEM, sun, earth, moon. So the earth comes between the sun and the moon, blocking sunlight from reaching the moon. During a lunar eclipse, the earth's shadow falls on the full disk of the moon, and total lunar eclipse is when the moon is completely within the earth's shadow. Okay, the bright disk of the moon at that time looks like dark red. We saw that around September 7 in the night when the blood, it became a blood red moon because the earth's shadow was completely on the moon, preventing any sun rays falling on the moon. So partial lunar eclipse is where only some part of the moon is in the earth's shadow and the rest is visible. Unlike solar eclipses, lunar eclipse you can see with the naked eye. It won't cause you any kind of harm. So this is the solar eclipse. This is how the solar eclipse looks, when the earth, when the sun is kind of getting covered like this, it looks like a diamond ring kind of a thing. And you need to be very, very careful while watching a solar eclipse. In fact, it's not advisable unless you go to a planetarium and see it through their extremely sophisticated equipment and telescopes. Okay, so these are some of the activities which you can do. Okay, these are some of the superstitions vagara that they say you should not eat, you should not cook, you should remove the cooked food, whatever has been cooked during before the eclipse, etc. Cook fresh. All those kind of different beliefs are there in different parts of the country. I don't want to get into it. It's called Grahan, Surya Grahan, Chandra Grahan in Hindi and in Sanskrit and in different languages. Now, what happens in the lunar eclipse? I've already told you. This is what, now if you see here, the sun is here, the earth is here, the moon is here. So when the earth's shadow is completely on the moon, it becomes completely dark, it becomes completely blood red, right? Otherwise, the remaining portion will be the partial lunar eclipse. If the moon is moving here, then it means it is coming out of the eclipse. So if the moon comes here, then it means that the eclipse has ended. It is now getting proper light of the sun directly. But when it is here, the earth is here, it means that it is getting completely covered. So it is basically an astronomical phenomena. It is called a total or a partial lunar eclipse. Okay. Now this is the Kodaikanal Solar Observatory. Kodaikanal is in Tamil Nadu. Okay. The western part of Tamil Nadu is located in the beautiful Parni. It's called Parni. There is a famous Lord Murugan temple out there in southern India. It was established in 1899 and it has provided data about the sun for 100 years. It's operated by the Indian Institute of Astrophysics in Bengaluru. Finally, we come to this gentleman called M.K. Vainu Bapu, who is known as the father of modern Indian astronomy. He led efforts and he set up the telescopes at Manora Park near Nainital, in Uttarakhand, in Kavalur, in Tamil Nadu. And the observatory which you have in Kavalur has been named after Vainu Bapu. He mainly studied stars, different stars, and even discovered a comet. He traveled to different parts. So this is about the scientist who you need to know. Again, it can come as a MCQ kind of a question. With this, we come to the end of the entire science syllabus for class 7. I hope it is absolutely clear. As I said, everything has been explained because my specialty is that I explain in great detail, right? Giving lots of examples, and I hope this has been of help. Please do this. I will also prepare at least 2 proper 80 marks practice test papers for science. I will put that on our website. You can see that and you can solve it on there, so that before the final exams you will get an idea about how to approach the entire 80 marks paper. You can time yourself. It will help you with time management, and it also help you to understand how much you have actually studied well, how much you have revised. So that will be before the examinations on our website. Studywithsudhir.com is where it will come closer to the exams. By the end of 2025 is when I hope to put it. Tata, bye bye. Thank you very much. Share the video and subscribe to CBSE with Sudhir. Namaskar.